Alright, so this section 5.2 quiz review is for my Concepts of Algebra 2 students. Again, your quiz is on Thursday over section 5.2, which is Vertex and Intercept Form for quadratics. So we'll go over some problems that will be very similar to the ones on your quiz, and again, I would suggest you write these down and bring them into class, and you may use them on the quiz. Okay, so here's our first question. We're going to graph this. Alright, we're going to graph this equation, y equals 2x, or 2, parenthesis, x plus 2 squared minus 4. Okay, so first thing is to realize that this is vertex form. Vertex form, y equals a x minus h squared plus k. And from vertex form, we can identify the vertex. That's the first thing we find. The vertex is the point h, k. So if we bring our problem down, the vertex in our problem is going to be, now, notice that h is minus h, right? So it's the opposite of this h. So that says positive 2 right there. So our h is going to be the opposite of positive 2, which is negative 2. The k, we take whatever the k says. If it's minus 4, that's the point minus 4. And there's our vertex. So I'll go ahead and graph that. Negative 2, 1, 2, negative 4, 1, 2, 3, 4. Then we need to draw our axis of symmetry. Remember, the axis of symmetry goes straight down through the vertex. It has the equation x equals, and it's whatever the x is of the vertex, negative 2. And now we have to find the right and left sides. Well, if this x is negative 2, then the next x to the right is going to be negative 1. I want to find the y when x is negative 1. So I'm going to plug it in. I'm going to plug it into the original equation to find the y that goes with that x value. Y equals 2, parenthesis, negative 1 plus 2 quantity squared, minus 4. And you can use your calculator to do this. You'll get negative 2. And there's the y value. And that's the point that is going to be on the right side of this axis of symmetry. Negative 1, negative 2. Right there. Oh, that's bad. And I draw the parabola up through it. Okay? Now I jump right across from this point, across the axis of symmetry, right to here. And there's my other point. 1, 2, negative 3, negative 2. And there's the left side. And that's the parabola for y equals 2, parentheses, x plus 2 squared, minus 4. Vertex form. Okay, here is the next problem. Another graph. This time the equation looks like y equals 3, x minus 1, x minus 4. Okay? This is going to be intercept form. Y equals a, x minus p, x minus q. Now, when you're doing intercept form, the first thing that you find is not the vertex, but the x-intercepts. That's why it's called intercept form. Now, the x-intercepts are the opposite of p and the opposite of q. This says minus 1. So my first x-intercept is 1. This says minus 4. So my other x-intercept is 4, 0. So you take the opposite. So if these were positive numbers, we would have negative numbers as our x-intercepts. Okay, so it's opposite. So I'm going to go ahead and graph those points. 1, 0's here, and 4, 0's over here. 1, 2, 3, 4. Okay, and now I need to find my vertex. Well, I know that the vertex goes right down the middle, right in between those. So to find the x of my vertex, we take p plus q, my q's a little tough here, and divide by 2. So I'm going to take 1 plus 4 and divide by 2. That gives me 5 over 2, and if I want a decimal, that's 2.5. I'm going to go where x is 2.5 and draw my axis of symmetry. 1, 2, and a little bit more, 2.5. And there's my axis of symmetry, x equals 2.5. So now I need to find the vertex that goes on that axis of symmetry. Well, that's the x value. To find the y, you plug it back in. Plug it back into the original equation. Y equals 3 times 2.5 minus 1 times 2.5 minus 4. And again, you trust your calculator. Can do it for you. All that multiplying of the decimals. And we get negative 6.75. So my vertex comes out to be 2.5, negative 6.75. I know that my vertex has to be on this axis of symmetry, so now I just go down 6.75. 1, 2, 3, 4, 5, 6, and a little bit more. Sure. And there we go. And I connect up. And I connect up. And there's my parabola for this one. Okay. Alright, so that's an example each of graphing, one in vertex, one in intercept form. Okay, so our next problem says here, rewrite in standard form. And it looks to me like we have a vertex form quadratic. Y equals negative, parenthesis x minus 3 squared minus 4. Now let's recall standard form. Standard form is y equals ax squared plus bx plus c. Notice, no parentheses, right? So we need to get rid of all the parentheses and come up with a form that looks like this. Well, it's a couple-step process. First thing is, we do the foiling. This is a FOIL problem. This is really x minus 3 times x minus 3. It's a FOIL problem. Two binomials multiplied. All right, x minus 3 times itself. So we FOIL using first, x times x is x squared. Outer, x times negative 3 is negative 3x. Inner, negative 3 times x, negative 3x. And the last, negative 3 times negative 3, positive 9. Then we combine the middle terms, right? They will combine because they're like terms. X squared, this is going to be minus 6x, minus 3 is minus 6, plus 9. That's step one. Now, we have this negative out in front. It needs to be distributed. So we take the negative and we bring it down in front as a negative 1. And it has to be distributed, so put that trinomial, that 3-term polynomial, in parentheses. And distribute the negative 1 to all 3 parts to get negative x squared plus 6x minus 9. So we've done the parentheses, we squared it, we've done the negative out in front, the number out in front, and now we have this 4 in the caboose. The tail end, we have to subtract 4. You can subtract it only from the number, minus 9. So we have negative x squared plus 6x, and negative 9 and negative 4 make negative 13. Do not forget about the y equals. That comes down in front. And there is your standard form equation. FOIL first. Okay, so here's our next two problems, and we'll go ahead and divide them. Alright, so we need to find the max or min. Okay, so remember, talk about the max or min. Now, we need to recall that if we have a parabola, if it opens up or it opens down, the vertex is that point we're looking for, the vertex. For this graph, the vertex is going to be a minimum because it's the lowest point. For this, the vertex would be a maximum because it's the highest point. So remember this. It's important to understand which way the parabola opens. Okay. So we're going to take a look at this first problem. Y equals negative 2, parenthesis x plus 1 squared plus 3. This is a vertex form equation. Y equals a x minus h squared plus k is the general form. We need to find the vertex. Now first, a is negative 2. If a is negative 2, that means you're less than 0, right? And if it's negative, that opens down. So we're looking at this picture right here. We're opening down where we have a maximum. So we're going to look for a maximum value. Well, vertex form is easy because it's just h and k. Opposite of h, same as k. Negative 1, 3. There's your vertex. The max is the y value. So for this problem, the max of 3 is your answer. Okay, so that's vertex form. Now, over here, we have another equation in intercept form. Y equals a x minus p x minus q. Okay, so we have it in intercept form. We need to first identify what a is. So a here is going to be a positive 2. And positive 2 is greater than 0. Greater than 0 means it opens up. And if it opens up, your vertex is going to be a minimum. So we're going to find the minimum value in this problem. Well, we have to find the x-intercepts first, our p and q. Remember, we take the opposite of them. So it's going to be 3, 0, and negative 5, 0, opposite of positive 5. Now we have to find the x of the vertex. The x of the vertex we find by taking p plus q over 2. P is 3, q is negative 5. This is really 3 minus 5, which is negative 2 over 2. Okay, 3 minus 5, negative 2 over 2. So your x comes out to be negative 1. So now I need the y. The y is the real min value. So if x is negative 1, find y by plugging x in. So we get negative 3 minus, or negative 1 minus 3, negative 1 plus 5. So again, I just plug x in wherever I see x in the original problem. And let your calculator do all the work. You're going to get an answer, I think, of negative 32. All right, negative 32. So this is the y of your vertex, which is going to be the minimum value, minimum of negative 32. And here's how you find the max and min of a quadratic function in vertex or intercept form. Okay, the last problem we have here is a word problem. Okay, we have a football. Okay, in this problem, the football kick follows this equation. X is distance in yards. Y is the height in yards. All right, and we need to answer the following questions. How far did the kick go? So how far and how high did the kick go? Well, the first thing we need to do is write this in intercept form. It's very close. However, it's missing 2 parentheses. To create that second parenthesis, just put this x minus 0. Create that parenthesis where this does not change x. This x minus 50 remains the same. Okay, so now we're in intercept form. First, identify your x-intercepts. Opposite, 0, 0. Opposite, 50, 0. And this is actually on our graph. These are these 2 points, 0, 0, and 50, 0. So we can answer the question how far the kick went. It went from 0 to 50 yards. So this is the part A. 50 yards was how far the kick went. Okay, so that's the answer to A. How far? Now we want to know how high it went. The height is up here at the vertex. We got to find the vertex. What is it? Well, we have our x-intercepts. To find the vertex, you need to find the middle of your x-intercepts. So that's the p plus q over 2. That's 0 plus 50 over 2. That's 50 over 2, which is 25. So this is the x of your vertex, but I don't care about the x. I care about the y. To find the y, plug it back in. Plug it into the original equation. Plug 25 in for x in both places, and plug it into your calculator. And we get a y value of 16.25. And that is in yards. That is the height of your kick, and that's your answer to part B. So hopefully this review helps you for your quiz tomorrow. Make sure you copy these problems down and bring them in with you. All right, thanks for watching. We'll see you tomorrow.